The Gerald R. Ford is more than a warship. It is a question. Can light itself become the shield of the future? In the silence of the sea, its steel towers above the waves, but its true strength lies in something unseen. The world is shifting. Drones, missiles, and weapons that move faster than thought threaten every ship afloat. Guns and rockets feel heavy against the speed of tomorrow. Yet within this career, a different answer waits. Not powder, not metal, but energy itself, transformed into defense at the speed of light. The USS Gerald R. Ford rises above the ocean like a floating city. At more than 100,000 tons, it carries its weight with quiet certainty, as though the sea itself bends to its presence. Its vast flight deck stretches wider than 4 football fields, a space built not just for planes, but for the rhythm of war in the air. On that deck, more than 60 aircraft can be launched, recovered, and prepared again. Fighters, surveillance planes, and helicopters turn the carrier into an airbase that moves wherever it is needed. Each takeoff and landing is smoother now, thanks to the electromagnetic launch system. The old steam catapults are gone, replaced by technology that spares the aircraft strain and readies them for faster cycles. Yet, what sets the Ford apart is not only its size, but its purpose. Every system is designed for speed, efficiency, and resilience in combat. Fewer sailors are needed, and machines carry much of the burden once handled by human hands. It is not only the largest warship ever built, but also the most forward-looking, a vessel created for battles still beyond the horizon. Deep inside the Gerald R. Ford lies its greatest secret. 2 nuclear reactors, each far stronger than those in older carriers, drive the ship forward. Together, they generate 300 megawatts of electricity, enough to light a small city. This energy does more than push the carrier across the waves. It becomes the heartbeat of everything on board. For decades, ships had to choose radar and weapons, speed or endurance. Energy was a limit, a chain that held back possibility. But on the Ford, power is no longer scarce. It flows constantly, feeding every system without compromise. Radars can scan wider, communication can stretch farther, and electronic warfare tools can run without pause. More importantly, this power makes room for what is coming. Lasers, advanced sensors, and experimental defenses all depend on steady currents of energy. Where older ships strain, the Ford waits ready. Its nuclear heart is not just about the present fight. It is about a future where energy itself becomes the Navy's sharpest weapon. The seas no longer hold the same kind of battles they once did. The threats that approach today are faster, smaller, and harder to see. Hypersonic missiles can travel at more than 5 times the speed of sound. They twist through the sky, shifting direction in ways that confuse even the most advanced radars. By the time they appear on a screen, they may already be seconds away from impact. At the other end of the spectrum are drones. They move slowly compared to hypersonics, but they come in swarms. Dozens, sometimes hundreds, can be launched at once. Each is cheap to build, yet together they can overwhelm a ship's defenses. Radars grow crowded, missile stocks run thin, and guns cannot fire fast enough. These 2 dangers, speed and numbers, combine into a puzzle that older weapons were never built to solve. The strongest carrier can be undone if it cannot stop what is coming. In this new age, armor alone cannot save a ship. Missiles and close-in cannons are still powerful, but they face limits against enemies that are multiplying and evolving at a pace never seen before. Against weapons that move too fast or arrive in overwhelming numbers, the answer may no longer be more missiles. It may be light itself. A laser does not wait for reloads or carry the weight of ammunition. It draws only on power, and when the switch is thrown, it fires at the speed of light. Such a weapon does not explode. Instead, it burns. A drone's eye can be blinded in a blink, its fragile frame cut through by heat no machine can withstand. A missile casing, heated to the point of failure, can collapse before it reaches its mark. Each shot costs little more than the energy to power it, dollars instead of millions. This makes lasers different from anything before them. They do not run out, and they do not hesitate. They turn energy into defense in its purest form. While storms, fog, and distance can still shape their limits, the promise remains the same. A system that can answer instantly, again and again, as long as the reactors keep breathing life into the ship. The Navy has already begun testing this future. On destroyers at sea, a system called Helios has been fitted to their decks. At 60 kilowatts, it is not the most powerful laser, but it proves the concept. Linked directly into the ship's combat system, Helios can spot, track, and strike small targets without delay. Its beam can be tuned to different purposes. At low strength, it dazzles and blinds sensors, leaving an enemy drone flying blind. At higher strength, it burns through metal and wiring until the target falls from the sky. Unlike missiles, it never empties its magazines. As long as the ship's generators run, the weapon can fire. Helios also carries another role. With its optics, it acts as a sharp eye, spotting threats from far away and giving commanders precious seconds to respond. In crowded skies, that extra awareness can mean survival. Helios cannot yet defeat the fastest missiles. Its power is too low, but it marks a beginning. For the first time, a ship defends itself with light. From here, the journey leads to weapons far stronger. To stop the deadliest threats, lasers must grow far stronger. Experts say a beam of 3,000 kilowatts could pierce the heat-resistant skin of a hypersonic missile. That kind of power is staggering, more than any current naval system can deliver. But it is the level needed if ships are to survive the weapons racing toward them. Such a weapon would not just fire once, it would hold its beam steady, burning through armor in a fraction of a second, destroying a missile before it could strike. It would also repeat the process again and again, handling many incoming targets without pause. No missile battery today can match that pace. But reaching that goal is not simple. Cooling systems must keep the laser stable. Optics must focus its energy across long distances without losing strength. And only a few ships can even dream of supplying the electricity required. Gerald R. Ford, with its vast nuclear reserves, is one of them. This is the vision that drives the Navy's research. If achieved, it would mark a turning point. A warship shielded by light could change the future of every ocean it sails. Not every idea has survived the search for new weapons. For years, the Navy placed hope in the railgun. It used magnetic force to hurl metal rounds at incredible speed. On paper, it promised range and power beyond anything seen before. But in practice, the weapon tore itself apart. The barrels wore down too quickly, the costs soared, and the dream faded. Another project, the guided projectile, aimed to turn ordinary naval guns into long-range precision weapons. It struggled with the same problem: too expensive, too complex, and unable to match the speed of modern threats. In time, it too was set aside. By ending these programs, the Navy made a choice. Instead of dividing its focus, it placed its future in one direction. That direction is light. Lasers now receive the funding, the research, and the urgency once spread across other projects. It is a gamble, but one the Pentagon believes it must take. Against hypersonic danger, there may be no second chance. For decades, ships relied on trusted shields. Close-in guns, fast missiles, and layered radar once made fleets feel untouchable. The Phalanx system, with its Gatling guns spitting thousands of rounds each minute, became a last line of defense. But it has limits. Its range is short, its ammunition finite, and against a missile moving at hypersonic speed, a second too late is enough to lose the ship. Interceptor missiles were meant to cover the gap. Guided by powerful radars, they could chase threats across the sky. Yet they too face hard truths. Each missile costs millions, and once fired, it is gone. A determined enemy, sending waves of cheap drones or dozens of missiles, can drain a ship's magazines before the real strike begins. Even advanced radar systems like Aegis cannot change the math. They see everything, but seeing is not the same as stopping. The oceans are no longer patient. Attacks arrive too quickly, too cleverly, for old tools alone. That is why the Navy now speaks of layered defense, with lasers as the piece that could close the gap. Time is slipping away. While the Navy builds its first laser weapons, rivals move faster with their own designs. China's hypersonic missiles already twist through the air at speeds no interceptor can match. Russia continues to showcase similar systems, reminding the world that carriers remain vulnerable. The Gerald R. Ford stands as both a shield and a target. Its reactors give it the strength to power weapons that others cannot. But the weapons themselves are still incomplete. Every month lost to testing or delay brings greater risk. Engineers work against the clock, knowing the first real strike could come at any moment. The question is not whether lasers will exist, but whether they will be ready before the enemy arrives. The Gerald R. Ford carries more than aircraft and weapons. It carries expectations. In its steel walls and nuclear core lies the Navy's hope that light can protect what metal no longer can. Lasers are still young, still untested in the fury of battle. Yet they may decide whether the seas remain safe for American ships. This is not just progress, it is survival. In a fight where seconds vanish, only beams moving at light speed may answer in time. The world's most powerful warship now waits for its final shield, a weapon made of energy itself.